Okay guys, today we're going to be working on 10-6, Growth and Decay. For this one we're going to learn about three different formulas that we're going to use. So let's start off with exponential growth. Let's go ahead and start with the word problem. In 1971, there was 294,105 females participating in high school sports. Since then, that number has increased an average of 8.5% per year. So, as you can see, this is a growth problem because obviously they are increasing. So we cannot use the exponential decay because they're not going down, and we're not going to use compound interest because it has nothing to do with money. So the formula, what we're going to use is we're going to use exponential growth. That formula is y equals c parenthesis 1 plus r to the power of t. Now, y is your final amount. C is going to be your initial amount. R is going to be your rate of change, and that has to be written in a decimal. Usually it gives you in a percent, has to be converted over to a decimal so we can add it to 1. And T is going to be your time. So let's go ahead and use this formula for exponential growth to solve this problem. Let's move on to C. C is the initial amount. So I do know that the initial amount is the amount of female participants that initially started in the first year, which was 1971. So that would be 2,000 or 294,105. Then we have the parenthesis 1 plus r, which is the rate of change. Remember, the rate of change is right here, which is 8.5%. We cannot write 8.5 here because we cannot add 1 to a percent. Remember, the way you turn a percentage into a decimal is by moving the decimal point twice over to the left, which is going to give us 0.085. T is the amount of time. So right now we don't know what that is, at least not for question number 1. So all we have to do now is simplify this. So the only thing we can do is simplify what's in the parentheses. So I'm just going to rewrite this number here. And 1 plus 0.085 is 1.085. Now, the reason that this cannot be simplified is because this number cannot be broken out of the parentheses by 294,000. The reason it cannot is because what's going to break this number out of the parentheses is the t. Since I do not have the time yet in question A, this is my equation. This is my final answer for my equation that it asked me to write. That being said, now let's move on to question B. According to the equation, which we just wrote and boxed in, how many female participants in high school sports, how many females participated in high school sports in the year 2001? Okay, now we have a time. So the time we have now is 2001. And the initial initial numbers we got started in 1971. So we're going to go ahead and subtract those. And that is going to be a difference of 30 years. 10 minus 7 is 3. 9 minus 9 is 0. 1 minus 1 is 0. So our time is 30 years. So I'm going to go ahead and plug that into our equation. Remember, our equation is written over here in the box. I'm going to go ahead and rewrite it. 1.085 to the power of 30. Now, you are going to need a calculator for this. So what we're going to do is we're going to use our calculators to figure this out. So I'm going to go ahead and go down here. I'm going to get my calculator out. Remember, we learned how to do this in class, how to type in any power we want. So I'm going to type in 1.085, and I'm going to put that to the power of 30. So as you can see, I have this number that's 11.5582. You can go ahead and round this, but if you have your calculator, just keep it on there and know that when I figure that out, all I have to do is multiply it by 294,105. So that's what I'm going to do. And it's going to give me an answer of 3,399,339.6 rounded. Now, I'm not going to go ahead and write this number out the way it is. It's okay to estimate in this case, so I'm going to go ahead and erase this equal sign because if I'm estimating, I don't want to write equals. I'm going to write about equal to. So it's about equal to 3.4 million. And there's my answer for B. Okay, guys, let's move on to this problem. Let's go ahead and read it. It says, use the information at the left, and it has a little story here for us. If the money the Native Americans received for Manhattan had been invested at 6% per year compounded semi-annually, how much money would they have in the year 2026? Okay, and then this little history clip over here says, as in 1626, Peter Minuit, governor of the colony of New Netherlands, bought the island of Manhattan from the Native Americans for beads, cloth, and trinkets worth 60 Dutch guilders, $24. So, obviously this is a money problem. So, and it's obviously talking about going to be growth, but so we're not going to use exponential growth. We're going to use compounded interest because it's talking about an interest charge. Let's go ahead and go over what the compounded interest formula is. So, compounded interest is what we're going to use. And the formula for that is A equals P parenthesis 1 plus R over N parenthesis to the power of NT. This one's kind of weird because the power has two variables in it which we will multiply together. So let's go over what everything means. A is the amount of investment. P is the principal or the initial amount of investment, the first investment they made. R is the annual rate of interest. N is the number of times the interest is compounded each year. And as you can see, you have two n's, one at the denominator of the fraction and the other one in the power. And T is the number of years passed. So let's go ahead and start filling everything in. So principal, the initial investment that they made. So the initial investment that they made, they bought it for $24. So that is the principal. That's what they started with. We add 1. Now R is the rate. The rate is 6%. Remember in the last problem we had to write 6% as a decimal, and it's the same thing here. So it's going to be 0 or 0.06 over N, the number of times the interest is compounded each year. So if you look over at the word problem up here, it talks about that interest is compounded semi-annually. Semi-annually means twice a year. So we're going to make that 2. Remember, the number of times n is the number of times it's compounded, so it's 2. And time. So in order to find time, I got my end date that it wants me to figure out, which is 2026, minus the initial date of the investment, which is, you can see over here in the story, is 1626. And I see this already. It is a difference of 400 years. So we're going to put 400 in this parentheses so we can multiply them together. Now let's go ahead and simplify it. Remember, A is going to stay because we don't know what that is. 24 is also going to stay here. We're going to add what's in the parentheses. So 2 goes into 0.06, 0.03 times, plus 1 is 1.03. And that is to the power of 2 times 400, which is 800. So now we just have to simplify this. Remember, for this, we're going to use our calculator because it's going to be pretty difficult to find whatever this number is to the power of 800. So it's 1.03 to the power of 800. And that gives me a big number. So I'm going to go ahead and multiply that by 24, the initial cost. And I get this number right here. It looks like it is about $446.6 million. So I'm going to go ahead and round that. So A is going to be about equal to $447 million. That's a lot of money. So that is the amount of the investment. Remember that if it has anything to do with interest, you got to use the compounded interest formula. Okay, guys, here's the last one we're going to do today. This one says in 1950, the use of coal by residential and commercial users was 114.6 million tons. Many businesses now use cleaner sources of energy. As a result, the use of coal has decreased by 6.6% per year. And obviously, once again, it has two questions that it's asking us, so we're going to get two different answers for this problem. Now, we have three different formulas we use. We have exponential growth, compounded interest, and exponential decay. So which one are we going to use? Now this looks a lot like the first one we did, which is exponential growth. However, there's nothing growing. Because of this word right here, which is decreased, we know it is not increasing, it is decreasing. So it can't be exponential growth. And it also cannot be compounded interest because there's no interest charge here. There's no interest, no money in this problem. So this is exponential decay. And the formula for exponential decay is a lot like the formula for exponential growth. So it is y equals c parenthesis 1 minus r to the power of t. So the only difference between exponential decay and exponential growth is the negative and the positive inside the parenthesis. So let's go ahead and get started with this. Once again, y is the final amount, c is the initial amount, r is the rate of change in decimal, of course, and t is the amount of time. So let's go ahead and get started with our first problem. It says write an equation to represent the use of coal since 1950. So we obviously don't know what y is. That's what we're solving for, so we're going to put it right there. The initial amount was 114.6 million. I'm just going to write 114.6 and I'll just add the million to the answer when we get there. In parentheses, we're going to have 1 minus r, which is the rate of change. The rate of change, remember, is 6.6 percent, but I cannot write it in percent form. I have to write it in decimal form, so that is 0.066. And since 1950, well, I don't really know what year it's going to, so I still don't have the time. I'm going to go ahead and simplify this. There's only one thing I can simplify on here, and that is what's in the parentheses. So we have 1 minus 0.066, which equals 0.934. And that is to the power of t. So this is your equation for the answer for A that told us to write an equation to represent the use of coal in 1950. So now we're going to go ahead and answer question B that says estimate the estimated amount of coal that will be used in 2015. So now we have our year to compare to 1950. So what we're going to do is we're going to put 2015 up here. We're going to subtract it from 1950 to check how many years that is. 5 minus 0 is 5. I'm going to borrow over here. 29 and 11 minus 5 is 6. So 65 years is my amount of time. So I'm going to take my original equation that I got for A, 114.6 million, remember, multiplied by 0.934 to the power of t, which is time, 65. So remember, this problem right here has to be broken out of the parentheses, and the exponent has the right to do it before the 114.6 million does. So once again, we're going to need our calculators. And what we're going to go ahead and do is we're going to multiply 0.934 to the power of 65. We're actually not going to multiply it. We're just going to do it to the power of that. So 0.934 to the power of 65. And it's going to give us 0.0, 11, 81, 80, 80, 80, 10, 59. Okay, so all we have to do now is multiply it to our 114.6 million. So 114.6, and that is going to give us 1.354. So I'm going to go ahead and estimate this to be about 1.35 million tons. So there's your answer. Y is equal to about 1.35 million tons.